Welcome to the Python Epiphanies tutorial. I named this tutorial Epiphanies because I am hoping, and based on experience teaching this a few times, I've got some evidence that at least some of you will have some aha moments during it, where you go, oh, that's how Python's really doing it. I've taught Python in to various audiences for quite a few years, university, kids, camps, grade 6, grade 10 to 12, industry. And one of the things I noticed is the intermediate Python. Introduction to Python, there's lots of good tutorials and books, etc. Advanced, there's some good stuff. Intermediate, it kind of felt like there were things that I was noticing and I wasn't seeing other people focusing on how to get past sort of a plateau that some people have when they're trying to move from beginner towards advanced, and they're in that in-between phase. The zip file at the bit.ly PyData NYC-Epiphanies has in it an Python notebook, a really big one that might crash your browser, has a bunch of smaller ones, one per section, and it has an HTML file. If you're going to, for the exercises, I actually encourage you to use the HTML file and type them in yourself. I think you will learn better. And you can do that in an IPython notebook, Jupyter notebook, or IPython, or just a regular Python, the read eval print loop, the REPL, which is just the prompt where you type Python and it starts asking you questions, or you start typing in expressions. I will be doing mostly one-liners. I'll be using Python 3.4. You can use an earlier version, including 2, whatever, and it'll be almost all the same. I'll point out a couple minor places where you might get tripped up. I have put errors in the code, including the exercises, on purpose, and I've thought about which ones to put in and why. It's to try to teach you something. This is not data specific. I'm not going to talk much about pandas or NumPy, or not at all. It's core Python. The thing so in terms of myself, I've been working in the industry for 25 years, using Python for about 10, 12. I currently am working as a software developer, software architect with a quant group in Toronto. They're using Python a lot, and I'm trying to help them use it well. I asked a question earlier before we started, so some of you weren't here yet, but I was trying to get a sense for where you're all coming from. And a few people had Python as their first language. I would say at least half the room has been using Python less than 2 years, unless all the people that arrived late somehow throw that off. And quite a few people came from other languages where the way that the way you may have been trained to think about variables is different than the way Python works, and you might not have figured that out yet. And that's one of the things I'm going to focus on quite a bit is names and objects. So much so that the first 10 minutes you might think this is way too slow. Bear with me. If you want to leave, wait 15 minutes and then leave. And then I use that as the theme going throughout, sort of talking about names and namespace changes. Any questions before I get started? Okay. Oh, one other thing I wanted to mention. I also have a version of this O'Reilly video that I did a couple months ago. It's a longer version of this. So this one's 90 minutes, sorry. This one's 90 minutes, that's a full 2.5 hours. And what I've done is taken just the best parts of that content to deliver to you. So hopefully that works. Okay, so let's start by just talking about objects very basically. And I'm gonna go really slowly to make sure you understand what's going on, right? So in this, hang on a second. Let me adjust some here. Can you still see that? Anyone in the back have any problem seeing that text? Okay, that's more reasonable. All right, so really slowly, what happens when I type 1 at the interactive prompt in Python? Python sees some syntax, parses it, figures out, that's an integer literal. I know how to create an object based on what the user is typing in. It goes off and it creates the integer object, which represents an integer, the integer 1. And that integer object is not just the bytes that have the 1 in it. It's a bunch of other stuff about the instance of the integer class. It's got a reference to the class, but other things as well. And you'll see that later when we look at sizes. If you look at the size of the object 1 that gets created, it's quite a few bytes. I think it's 24 or something like that. Okay? And then, when I hit enter here, because the expression that I asked Python to evaluate has a value which isn't none, it prints the value of that expression back on the standard output. Okay? So that's actually what's happening in the eval print loop. So I can create objects via literals, and none of these should be surprises. I'm just creating, there's a float and a complex. There's a string literal, a bytes literal. Right? There's a tuple. A list, a dictionary, a set. Right? Another way you can access objects in Python is they're pre-created for you. False and true are an example, right? So if you look at false and true, or look at none, which is interesting. Is it stuck? Is it not answering? I thought I evaluated line 11. Ah, right. If it returns a value which is none, it's not going to print it, right? I told you that. In the REPL, the expression is only going to be printed out if it has a value that's other than none, right? So the false and true are names that refer to pre-created objects that represent false and true. None is a name that points to or references a pre-created object. There is one object in Python, which is the none object. And I can't see, in a sense, again, I can't, when I hit enter on it, it didn't show me anything because its value is none. So that's kind of a weird case. And just a couple others that are not implemented, ellipses, et cetera. There are a bunch of built-in types and functions. Here are examples of two built-in types, int and list, and two examples of built-in functions, function any and function len. So everything in Python at runtime is an object. Everything in Python is an object. It has a single value, a single type. It has some number of attributes. It has one or more base classes, might be more because Python has multiple inheritance. It has a single unique ID, and it has one or more names, or occasionally zero, and those names are in various namespaces. Okay? And I want to explore these briefly. And again, for those of you who just arrived, and for those of you who are starting to get bored, trust me, the first 10 minutes it's going slow. I'm trying to articulate this in a very consistent way that makes that will help you think about Python the way I think you should think about the way Python's working to help you go faster in Python and understand what's going on. So every object has a type, right? And we can look at the type of int. And again, let me slow down again here. What happened here is Python saw the 1, created an object that represents the integer 1, took a reference to that object, sent it off to whatever the name type refers to, which happens to be a function. That function call, that function took that reference, did whatever magic it did, and it created or returns a new object, which is an object that looks like int when it gets printed out. So it returned the type, which is the int type. Is int an object or a type? Both. It's a type, but everything is an object in Python, so it's definitely an object.
So what's the type of type 1?
It's the type of type 1. Try it out, but it's meta-type. Float, complex, type str, type bytes. Again, you'll see stuff. This is some of those. So the bytes one, you'll see this is Python. Well, Python 2 it works as well. There's a list, a dictionary, a set. So I'm just going through the same sets of stuff I did earlier. Oh, the type of none. This one doesn't show up as nothing. It's not blank. It actually did show me a value. In this case, the type of none is the none type. All right. So there's this singleton type, the none type, which has one instance, which is none. Actually, don't quote me on that. I'm not sure how it's implemented. Probably is implemented in C, but I don't know. Every object has some number of attributes. So true is a name in the current namespace, which refers to an object. If I use dot and then some valid Python identifier after it, I'm asking Python, go get the attribute in that namespace. It's an object kind of has a namespace, which is its attributes, and return that value to me. And I get this string, right? By the way you pronounce this, if you haven't heard, it's true.dunderdoc. Double underscore doc, double underscore is pronounced dunder, dunderdoc. So true's dunderdoc attribute is just a string, which is pretty similar to the help that it's the doc string, and it's the help that if you type help true, you'll get back some of that. You'll get back all of that and some more. Here's an object. So here, what's going on? Again, slowing down to brainwash you a little bit here. The object, string literal, creates a string object. That string object, I'm asking it, does it have, please go try to fetch the name dunder add from it, which is going to be a method. And it gets back a method wrapper add of string object at and gives some memory address. Right? Is that callable? I'm going to call the callable function. All right. So again, slowing down. String object gets created. I ask, can we get the add attribute from it? That object is returned. It's passed off to whatever function callable refers to. That function returns an object, which when printed shows up as true. That's all the layer that's going underneath. And I'm not saying you should think about this all the time. Usually you want to think at a high level of abstraction, but I think it'll help you. So yes, add is callable, and we can call it that way if I just want to do addition on a string. You can see the exclamation point now shows up on there. Every object has one or more base classes. You can actually get at these through attributes, and we'll look at these a little bit later as well. But if you look at true's dunder class attribute, it's bool. And if you look at the dunder class attribute's dunder bases attribute, bases is the plural of base, because it might be more than one, it returns me a tuple of all the base classes. Well, there's only one. Most objects in Python, most classes in Python only have one supertype, and this one's true as well. Interesting that true, which is a Boolean, is implemented as a subtype of int. Right, so bool is a subtype of int. The superclass of bool is int. One of the things that I find interesting, Laura Creighton had a post a long time ago when bool was added to Python, arguing against it, saying this is not a good idea. It makes it harder to teach. In case you're curious, you can go and search that. I can look at, let me just pull out the 0th element of that tuple and look at its base classes, and I get object. Right? So true is a subclass, is an instance of bool, subclass of int, subclass of object. Yes?
Then is instance is calling both the dunder class and dunder bases?
So what I'm doing, sorry, where? Line 32?
Is instance, the function.
Oh, is instance.
Think of both class and bases?
Let me think about that or answer it later. We'll keep moving. Good, that's an interesting question.
Why wasn't object the base class of bool? If bool is an object, it said it was an int.
Good catch. So when I say subclass, I would mean a direct subclass. I think it'll become more clear. So the method resolution order for classes is stored in the dunder MRO attribute. So I can look at bool's MRO, and it will give me a weird error. Oh, no, it doesn't. It gave me the right. I got confused there. So there we go. I think that might answer your question,
Yes.
right? The right way to do all of this, if you need to, is with the inspect module. And this will give us an error because, why? Okay, well, there's I just happened to I got the doc string for that simple function right in my error message, and I can see it returns the tuple of base classes. So I'm supposed to pass it a class. I passed it an instance, right? So let's pass it the class or the type of true, and there we get. That's the right way to do it. All right, int object, string object. Python 3, you'll see base string in there somewhere. Okay, almost done the slow stuff, and we'll start doing more interesting things where I'll reinforce the language of names, etc. So ID of 3 in Python, the ID is a function that will return a unique identifier for an object. In CPython, currently, it happens to return a memory address. And that's useful in a few edge cases when you're doing stuff with external extensions, typically. You should not rely on that. It's not true in every implementation of Python, or guaranteed to be. But you can check the int, so you can check the IDs of all these things. So the other way we create objects is to call functions, or classes, or dunder call methods, right? So we call other callable objects. Functions are the primary example of callable objects, but there are other ones we'll see. So let's look at an example of that. There's len is a name which refers to this object, which is a built-in function. And I can say, is it callable? Yes. I can call it on a string, and I get 16 is the length of that string. There is a dunder len attribute of every string type's instance, every object of type string. And you can call that directly if you want. That's what len actually does. It looks to see if it has one and calls it. Int is callable, right? Remember, int, I did a type of 1, I got back int. So int as a built-in name is a type, but you can call it, just like you can call classes. And if you call it, it does things, and you can explore the various things it does. If you call it with no arguments, it'll return sort of the base value, or the default value, or it's probably a better word for that. Same for dict. If you call it, it returns an empty dictionary. You can actually call it like a function and pass it parameters. You've probably seen this. If you haven't, it's handy. Slightly better syntax in some situations. Limitation, of course, is the names have to be valid Python identifiers. And of course, the order you get back, why is it different? Well, because dictionaries don't have order. They're implemented to be fast for key lookup, not to be ordered. If you need an ordered dictionary, you can use collections ordered dict type. True is not callable. And if I try, it'll tell me it's not callable. But bool, the type itself, is callable, right? Okay. Some information about exercises. I want to give you a chance now for just about 3 minutes. Just go try these exercises and just explore and think about what you just learned. So we'll start again in about 3 or 4 minutes. No, that's an attribute. So that's. I can't turn it off. It's an attribute of the object. That attribute happens to be a callable, which you can call it. It's a method.
I see.
So those of you who don't have the, aren't trying this yourself, look at that and predict what it's going to do. Those of you who are trying it yourself, do the same thing. Before you, don't just type it and hit enter. Look at it and say, okay, what's this going to do? Think about what it's doing, and then see if you get it right. Okay, I'm going to hurry us along now. I know that I expect none of you finished that set, and that's okay. Partly it was just a stretch break for your brain. Stop listening to me. But I encourage you to try these later. And again, if you want to try, there are a couple exercise sections for sections I am demoing that you can get excuse me, from the O'Reilly video link to the full set. Feel free to go through that on your own. So let's just try these, see if there's anything new to learn. Usually there are when I have you do exercises. What does dir do? Dir is a built-in function that if you pass it an object, i.e. if you pass it something, because it's got to be an object if it's Python, it'll show you all the names of the attributes that are available on that instance. So lots of stuff. There's the 5.0.add. 5.0 is a float, and there's the add method wrapper. We'll see that later again. And it's of the float object that got created or found when the 5.0 was evaluated. Remember, it went off and created the float object. Is that method wrapper callable? Yep. So let's call it. Is this going to fail or succeed? Yeah, we're not adding to anything, right? How does it fail? Well, expected one argument got 0. All right, so we'll pass it one argument, we get 9. What's going on here? 4.add can't find it. Why? Well, because it sees the 4 dot, oh, here comes a floating point number, and then it's not a floating point number. So there are some things in Python, there's 3 or 4 little weird edge cases in syntax which are interesting. In theory, I think they probably could correct them and it would just slow down the interpreter. So if you put parentheses around it, well then I can say that interrupts the syntax confusion for Python. And again, I get the method wrapper, I can hit add. If you're curious how big things are, you can import sys. I've given it a different name here just to save you typing. So there's a string Oh, interesting. 53 for a string of 4. 28 for an integer. And then, especially if you're running Python 2, you might see some interesting boundary conditions here in terms of what gets returned. No, probably not. Anyway, those are some very large numbers. Python, if you get past the maximum integer size of your platform, it will magically start using long ints, which are slower, but you can use them. Okay. So first foundational piece, make sure we're all on the same page. Second one, I'm going to talk about names. Yes?
Why is it that in Python 2, the size returns the value of the
I don't know. I haven't explored that. How different?
Well,
A little bit?
I got 38 for the size of W, and I think it's 50.
Okay. And are you running 32-bit or 64-bit?
I'm
64, I assume, yeah. I'm not sure. So names. You got to understand names in Python. And I'm going to show you a bunch of stuff about them. And again, I'm going to slow down. So this is going to go. I'm going to go really slowly and articulate very carefully. And you'll notice I almost never use the word variable because most people, when they think variable, they don't think about something that can vary or math variable. They think of the variable I learned in another language or that I'm used to from just the general understanding of variable in programming, which isn't quite consistent with what Python's doing for a lot of people. So every object has, as I said earlier, 0 maybe, but usually one or more names in one or more namespaces. So names are just references to objects, and they work just like dictionaries. Namespaces work just like dictionaries, and we'll see that. So if I call the function dir with no arguments, it says, show me all the attributes of the current namespace, or all the names that are available in the current namespace. And you will get a lot in IPython if you're running the notebook. And so we're just going to skip back there. And I'm instead going to create that file and then load it back in and execute it. And then I can just say, OK, show me what the names are. OK, there's nothing. So now I've got nothing, because I basically remembered all the ones I had, and I'm saying ignore those. But this is a lot closer to what you'd see if you just did the REPL. You would see almost no names in your current namespace. So nothing here. So if I type A, Python sees a Python identifier and says, that must be a name lookup. Let me go look in this thing that's very much like a dictionary, the namespace, and see if that key has a value in it. If so, I'll return the value. That's how they do it. In this case, we get a name error because there is no key in that dictionary or that dictionary-like thing. Okay? So what this does, A equals 300, this is a namespace operation. This is a change to the namespace. You might hear people say this is creating a variable. It's not creating a variable. In a high-level sense, it is, but it's not creating a variable in the usual sense. Remember from when I was talking so laboriously slowly earlier, the number 300, Python sees that and goes off and creates an integer object representing the int 300. All the A equals does is says, I want to remember that thing, right? It's like I wrote on a Post-it A, and I stuck it on that object. That's one way to think about it. The other is to think we've got this dictionary, and it says, there's that object out there. Let's add A as a key in the dictionary, and the value is going to be a reference to that integer object that got created as part of that expression. Okay? So if you think about Python, if you think about variables as boxes where you put values, that can be a little bit misleading and get you in trouble. Part of why that can part of why. So the reason that way of thinking exists in our industry is because that's the way compiled languages, all of them used to have to work that way. And the reason they had to work that way, that's why types were that way, right? Python, the type is carried in the object, the 300. It's not carried in the name. And it happens at runtime, not at compile time. In other statically compiled languages, the type has to be known at compile time because the compiler has to know how much memory to allocate. And if you say 300 plus, if I say A plus 1, it has to know what machine instructions to issue to do the addition. Because a float add and an int add and a string concatenation are different machine instructions. Python, that's all done at runtime. OK, so let's change the namespace. Aha. Look at that. There's my namespace. It changed. It now has a name A referring to the object 300. Now here I don't see the reference. I actually see the value because it's dereferencing it for me. So now when I access A, Python looks up in the current namespace for the key A, the name A, and if it finds it, it returns whatever A refers to. Amazing. Just let that sink in, what that's doing. That's very handy, because then I don't have to put quotes and curly braces and everything around it. So it's just like a dictionary where I can get some free syntax. So here's roughly what I've already described, so I won't repeat it. Now, A is a name in the dictionary, which is in the namespace, which refers to 300. If I say A equals 400, that's a reassignment. And all it's doing is the 400 gets created out there somewhere, and I'm saying, have A point to that 400 instead of whatever it pointed to before. Right? So I'm not taking what used to hold 300 and clobbering it with a 400. No, 300's out there in memory, 400 got stuck out there in memory, and I'm just saying to the namespace, stop having A refer to 300, have A refer to 400 instead. Okay? Namespace operations here. So now we can see A refers to 400. So what's B equal A going to do? Yes, question.
So what happens to 300? Does it get garbage collected?
Does the 300 get garbage collected? None of your business. Right? And I joke, but the point is it really isn't. If you have to worry about that, sure, worry about that. But typically when the reference count on an object tracks how many references there are, how many names there are, indirect or direct, in all sorts of different namespaces to an object. When that goes to 0, Python has the right to go clean it up. And it usually will do it right away. And I'm saying usually because I'm talking Python generally, not Python, not C Python, not a specific version. Different implementations can do it differently. Okay. All right, so when I say B equals A, what I'm doing there is I'm saying, I already did that, I'll do it again. Notice it didn't print anything here because the expression B equals A is actually not an expression, it's a statement, doesn't have a value, unlike C. So what I said is dereference A, go look up what A refers to, and I want B to be a new name in the current namespace that refers to the same thing that A referred to. So now B and A are two names for the same object, right? Now if I access A, I get 400, 400, and if I do the dir n, you can see, sorry, go away. You can see right up there is where the 300 and the 400. Now this, again, this is a little misleading because you see two string representations of it printed out. There's only one 400 object out there. Well, actually, I don't know if that's true or not, but we'll look at that later. You can look at their IDs. Oh, no, I do know because we did an assignment. Sorry, their IDs are the same, so they are the same object. And A is B. So is an operator in Python that checks to see that the two expressions, in this case names that get looked up, are they the same object? It's not equality, it's are they the same object? Okay, and that we'll touch on later again, but it's important to understand. Okay, so del A. Anybody want to take a stab at what del A does? Be brave.
Removes A from that magical dictionary namespace.
Removes A from the namespace. Del is a namespace operation, right? It's just changing the dictionary. It's removing the key. Get rid of that key value pair, right? And again, because I got rid of the name, the reference count on the object would represent the integer 400 decremented. Did it go to 0? Del A is done. No, because B still refers to it, right? If I now look for A, it says name error, but B is still there. So if I say B equals walk, again, I'm going to skip the comments because I'm talking through them instead. B equals walk, again, in a compiled language where I said B is an int, then to say B is not an int, it's a string, is going to be a problem because it throws off the whole compile chain and the instructions being issued and the type checker doesn't like it, so that it can do all those things. Well, in Python, B is just a name, and I can have it name refer to some other object. So there, I did. And there's B, and it's got an ID. All right? And then if I, now at this point, has 400 been garbage collected? Probably. And if I try, oh, I did that twice, sorry. So if I try del B, it removes it, and then I evaluate the same cell a second time. Right? And if you look, there's nothing there. So I mentioned that objects, quoting from the tutorial, the Python tutorial, object attributes are also like dictionaries. And in a sense, the set of attributes of an object also form a namespace. So I think that's a good way to think about it. In Python 2, you can create a namespace, a simple empty object, a class that does nothing that way. You can actually import from the types module after Python 3.3 to do the same thing. So let's create one of these trivial objects. I now have an instance of a simple namespace class. It's just basically, just think of this as an object, or it's a record type or something like that. So if I look at it, it's going to give me some kind of whatever. It tells me what its type is. Well, it tells me it's a namespace. So if I look at its dictionary, it's got nothing in it. If I set some of the attributes to certain values, i.e. if I add attribute names to the namespace which that object has or is, and make them refer to the objects that just got created, then if I look at the dunderdict attribute of the object, we can see that's exactly where it stores them, right? And then I can access them same way. All right, so that's the way namespaces work when you think about attributes of an object. So earlier I made some kind of vague comment about ints and did the 400 get cleaned up and are they the same? Well, they were in that case because I said A equals 400, B equals the same thing A is. So they were referring to the same object. This is not surprising, or maybe it is surprising. I don't know. So I equals J is not surprising. That should not be surprising. 10 does equal 10. And for some of you, because, yeah, is it surprising or not? Some of you, this will be surprising or not surprising. The behavior is different, right? So don't use is unless you mean it. Use equal if what you're looking for is equality. What's actually going on here is that Python pre-creates some integers and others it doesn't. And it does that for efficiency reasons. And you can actually check, right? So I is not J, but still I equals J. 500 does equal 500. So in this case, we can intuit that there are two 500 objects out there in Python's memory right now. In case you're curious, and it tells you why there. In case you're curious, let's just go look. And I narrowed this down, but you can see that right around between -6 and -5, we start to get different memory addresses. And above 256, we get different memory addresses. So you can go look at the C code and figure this out too. But just from the Python level, you can see, oh, so Python pre-creates integers in the range -5 to plus 256. Because they're so commonly used, it makes sense to do them up front. Is this going to help you in your coding? No, not at all. But it's kind of neat. All right. A few minutes to do some exercises with dir. Again, if you're doing it in the, you only need this def dunder dir if you, or underscore dir, I mean, if you're doing it in the IPython notebook and you don't want all the noise. So take 2 or 3 minutes, take 5 minutes and do some exercises there. Yes?
If you're, the attributes that you showed that went into the namespace dictionary, you were able to access them with dots. Does that mean any old dictionary you can access the items with dots?
No. So are you saying does every object have a...
X and I put 2 keys, Y and Z, can I say X dot Y?
No.
I thought maybe syntactic sugar just carried over.
No. So let me get past that for the people who want to just imagine what's going to happen. Okay, I'm going to hurry us along again because I'm choosing for you that you'd rather have more. In only 90 minutes, you don't need as many breaks, and you'll get more from it if I show you more stuff. So I'm going to do a dir, remind you that, oh yeah, again, if you're running IPython, you see it. So I'm going to create my little fake one here, get rid of the clutter. V equals 1. V has the value 1. What's in my current namespace? Just V got added, new to it. It's type int W equals V. Remember, that's just saying whatever V referred to, make W a new name if it doesn't exist already, or change it if it does, so that it also refers to whatever V was. Right? And of course, if you do that, then V as W is going to be true. Here's a little list, 1, 2, 3. So now N and M both refer to the same list. And you can see all those names are in there, V, W, N, and M. M is N, yeah, because they refer to the same list. So if I change list M, does list N get changed? Well, hopefully that's a nonsensical question. Why would you ask if why would you call them list M and list N? They are the same list, right? Therefore, if you change it will change. Right? And you can see that. Attribute, there's a method there. Let's change addition to be subtraction. Phew, glad we can't do that. Let's import get ref count from sys and give it a short name so you can type it when you're working on these later if you want. Wow. I start up Python, I start up IPython notebook. There are 16,000 references to the none object already. Anyone who's running Python, just bare, how many are there? Call it out if you figure that out. Just, it'd be a lot less than if you're running IPython notebook or Jupyter notebook with IPython in here. How about the, how many?
1037.
1037?
Yeah.
Already 1,000, just running Python, okay. Object, the base class of all the other classes and of which instances are a sub, are instances of those, already 2,500 of those. If you call object, remember I said you call bool, you get false, you call int, you get 0 if you call it with no arguments. If I call object with no arguments, I get a new object that just exists and it's unique. And if you ever need a sentinel value, this is a great way to get it, right? Because now this value, there is no other value that you can throw me in a file or over the network or typed in that is going to be the same as the sentinel value, right? If you're ever, you occasionally need this, right? It's like, what can I use? -1, because all the others are positive. How do I know when I get to the end of this, whatever I'm, some kind of way of stopping when I'm done processing some things? That's one way to do it. Of course, there are other ways to do it with, to stop processing, like exceptions. But anyway, I create this, and then let's say how many references are there to it, and there are 2. Anybody, what are the 2? Someone mentioned this was mentioned yesterday, I think. So one is the name sentinel value in my current namespace. What's the other reference to sentinel value, to the object that I just created? Anyone? Yeah?
Underscore?
Nope. Because underscore here, refs, again, sentinel value equals, that's not an expression that has a value. It's just an assignment. Refs is going to return the 2. So it's in the refs function itself, in the getRefCount. In getRefCount, there is a name defined as a parameter in the signature, and in the content, in the body of that function, the refCount function refers to whatever it was passed in with a name. That's the second one, right? So it's a little bit of a trick question because how many references are there to that object right now? Well, there's only 1. But when refs was running, there were 2. As soon as ref returned, there was only 1. Interesting. 3 in the REPL. I'll explore that later, yeah?
So running IPython notebook with Python 2, I guess.
Well, IPython notebook, it's interesting. I wonder why that is. I mean, I expect it's because IPython notebook is saving some things. And it may be even saving, what would save? Be interesting to track those down. Okay. So you can use object if you need to, and the only time this expression will be true is if it's actually the value that you... Oh, typo, look at that. Oh, no, that's true here as well. I was going to say the only time it would, right. Having a little angst here that, is that true for equality as well as, I think it is. I think if you take object equality, it also is always going to be, I've never thought about that. This ought probably to have been an is. No, it is equal. In a sentence value, you would want it to be equal. Anyway, it doesn't matter very much. Let's look at a few others. Refs. So does it make sense to pre-create Python integer objects that are between -5 and 256? Looks like it probably is. If you want to know the whole list. Ooh, look at that, a whole bunch of them. It tapers off near the end. Interesting to do this for a lot bigger range of numbers and see, you can go make the case that we should start pre-creating more maybe. Tuple assignment, it's kind of nice in Python. You've seen me doing that a few times, or at least returning ones, right? So I can assign, as long as the length of the iterable, notice I said something very general, it could be a list, could be whatever, is the same as the number of names you're trying to assign, you can do that. You can also do the swap trick, which you don't need the temp in between because of that, the way that works. And it worked just fine. We got 2 and the 1. So there's a tuple. There's another tuple without the parentheses, but it's still a tuple. There's a list. There's a sequence that's iterable, right? All of these work. In Python 3, you get some pretty cool iterable unpacking, which is nice, right? So I can say I, j, k, and all the rest, and I get a list. I can say, you can put the star, in the middle, right? And you get that. You can even do it like that. Only 2 items on the right. So that's very handy in some situations. Like it's just very nice to have that in Python 3. Okay. Namespaces, a little bit more. Scopes and search order. So anything new here? A scope is a section of Python code where a namespace is directly accessible. You can just type the name, and Python says, oh, you must be checking the current namespace in the scope, which again, that was not said very well. You want to know the current scope, which may include enclosing namespaces. For indirectly accessible namespaces, use dot notation. And we've seen that already with objects. Direct namespace search order. Innermost scope contains local names. Namespaces of enclosing functions, starting with the nearest enclosing scope. Middle scope contains the current module's globals. Outermost scope is the namespace containing built-in names. Have you noticed that in all the dir, all the calls to dir, you've never seen len, but I used it. You've never seen callable, but I've used it. So that's where the built-ins comes in. You can go explore that as well. It's interesting. So here's the real story on namespaces. All namespaces changes, all namespace changes happen in the local scope. Okay? So assignment, reassignment, del, import is a namespace operation. It does more than that, but it's a namespace operation, right? Because what does it do? You say import space, and then you give it a valid Python identifier. And Python, in that case, doesn't go look in the namespace to find what that name refers to, because it won't be there. But it goes and finds a module somewhere that has that name and makes it true that it's in the namespace. So it both goes and imports it, creates this imported object, and then it adds something to the current namespace. Def, defining functions, create a new name. Class creates a new name. Function parameters, the name in the signature creates a new name in the scope of the function. In a for loop, you can create a new name, right? Exceptions, with, and doc strings do it implicitly. If anyone finds one I still missed, it's quite possible. Let me know afterwards and I'll add it. So you should never reassign built-in names, so let's do that. All right, there's the built-in function. So F1. So in here, I'm going to print out what value did, where's, think about where, when this function gets evaluated and then executed, it's going to get evaluated in this cell, executed down here. What is len going to refer to? I suspect it's going to refer to the built-in function here. But then right after that, I'm going to change the namespace in the function by adding a new name, len, which is going to be a reference to the code object, the function object that gets compiled when this function gets read by the Python, And then inside that function, I'm going to add a new name, len, which is a range object. And I'm going to print what it is, because I'm curious. And then I'm going to return it. Print that one, return it. Again, in the details of this, I mean, I want you to think about, this is okay, you can do this. Again, not a good idea, because your reader's going to be confused because len's a built-in, but this helps you think about how namespaces work and how scopes work and how looking up names works. So we'll define that function, and then we'll call it. Never make last-minute edits to your slides. I forgot that oh, no, actually, that might not be the problem. I added this and didn't, thinking, oh, wouldn't it be nice to show that as well? All right, let's skip that for now and come back to it. And then here is a slightly different example, small change. All right, so getting back to this, assuming, sorry, that didn't work. We'll go fix it later. I want to fix it later because I want to show you something else first. So len is now the built-in function len, right? Let's overwrite it just directly with an integer object, 99. Overwrite it. Oh, terrible language. Let's make the name len refer to that integer object instead of the built-in function it used to refer to. All right, so now if I define this function and I call it, what's it going to do? What error is it going to give? Think about that. You have the intuition it's not going to work, or maybe you know it's not going to work, but what error is it going to give? Yeah, len is going to say, you can't call a string. Oh, sorry, you can't call an int, right? Because I said len s equals, that was what s referred to as that string, and then I'm going to call 99 passing it walk. It doesn't make any sense, right? So that's the error we get, right? And of course, len hasn't changed. And I can delete it. Oh, I've just deleted the len function, right? No, I've just uncovered it, right? Because there's the built-in namespace, the global namespace. When you add something to one namespace, it covers up the other one, but when you delete it, it only deletes it from the current namespace, because it's a namespace operation, and all namespace operations happen in the local namespace. And so then the built-in one is visible again. Okay? And then println is going to work for us. Thank you. Pass. Let's try that with pass. Oh, can't do it with pass.
You can't use both names at the same time, right?
Both namespaces?
Yeah, the system built-in namespace and the redefined namespace.
Not easily.
You can't just use the context.
You could, but it'd be awkward, right? Like you should not overwrite.
It allows you to redefine.
So built-in names are loaded at runtime, and you can mask those names or hide those names by adding a local name, local to your whatever your namespace is, which might be inside a function, nested in a function, et cetera. Yes. So you can add names which shadow the built-in names. You can't do things, some things you can't do though, right? Like pass, it's invalid syntax. So some of these things are keywords and you can't override them or hide them. Others are just built-in names. Yeah.
Would it be possible to refer to the built-in name from the content?
Not easily. Not easily.
Is there a dictionary or how?
There's a built-ins module you can go explore. And that, I assume, would still have a reference to it.
Qualified name dot notation.
Qualified on what? On built-ins?
Yeah.
Yeah, you could probably do that. Don't do it. Yeah.
Why didn't that make all built-in functions keywords?
I don't know. I don't know. There's some power that comes with allowing you to override things, mask them. Dangerous, but yeah, that's an interesting question. There are plenty of people around here, the halls, who could answer that. Ask Brett, he might know. Okay, so let's look at some surprising behavior related to function locals. X, I'm going to make a new name in the local namespace of the REPL, which is going to refer to the integer object representing the integer 1. You getting tired of me saying all those words? It's hard, isn't it? All right, and then I'm going to call it, and it's going to print in test outer scope in the name of that function, x is equal to 1. Cool. How about let's create a local here. So x equals 2. Oh. Why isn't x 2 here? Oh, because I haven't called that function. I've only defined it, right? So x is 1 from up here. I've defined a function test local where I'm going to assign a local x equal 2. This namespace operation is going to happen in the local scope of the function. Right? So now when I call test local, I should see x equal 2. Phew, it's working. And x will still be 2, or will be back to 1? Back to 1. All right. How about this one? Looks pretty similar to the other one. I'm going to print what x is, which should give me the x equal 1. Then I'm going to set it equal to 3. I could print it again, I suppose. Let's just double check. X test unbound local. So anyone run into that error and go, oh, what's going on? You probably figured it out. Those of you who've run into it, you figured it out by now, hopefully, or maybe not. Those of you who haven't, what's going on here is that namespace operations, so here's a namespace operation, x equal 3, that happens in the test unbound local function. And when Python compiles the code, it says, oh, they've assigned x in this function. Therefore, x is a local. And then when it executes the function, it says, oh, they want to access x, and x is a local. And so it tries to access x, which is a local, but it hasn't yet been set up, right? So unbound local, it's the closest thing you get to an uninitialized variable in Python, if you are familiar with that term. Well, we can actually go look at this. It's kind of cool. Let's go see behind the scenes. All right, so test unbound local is a name which refers to the function object. Let's go look at that object. Let's look at its code. All right, and we can see some things about its code. There's its argument count. There are no arguments passed. The signature has no arguments, no parameters. The name of the function is test unbound local. Now, you notice that this name shows up twice, by the way. Test unbound local, right here, def test unbound local, creates a function object which has as an attribute the string test unbound local. It also inserts the same string, test unbound local, into the current namespace. So that name sort of goes two places when we did the def. Anyway, so there's its name. And we can look at the names used in there. There's a print that gets used in there. And here are the number of locals and the names of the locals, right? So by the time this code has been compiled, Python knows that there's a local name x. So when it tries to access it, well, let's really see what's going on. All right, when it tries to access it, here's the bytecode that Python constructs, right? So store fast is the assignment of x equal 2. So the load const store fast pair, no, where is this? Load global, load const, load fast. I'm not going to get stuck here. We're short on time. But it's the use of x by load fast here. There we go. So load fast of the x, I think, is happening right here. And then we call the function, which is the print, trying to use it. But what's the load fast that fails, right? So sorry, I can't. And it's interesting. The fact that it's called load fast is related to fast locals, which you may have heard of, which is something that is an optimization in Python. Anyway, that's deeper than some of you wanted to go, maybe. And here's the exact, from the frequently asked questions in Python, the exact explanation of how of why an unbound local happens. So you can go read that later. If you want to explore some stuff on your own, there are a few other things you can look at. Try the difference and see how that shows up. How about global? What does global do? Well, let's define it. Right, so x is still, was it 1? Yeah, it was 1. And so what global does is it tells Python, okay, I don't want you to create a local in this case. I want you to use the one that's global instead. And so in test global, when we call that, it's going to first print the 1, assign it to 4, then print the 4, of course. And then x is going to be 4 when we're done. Right? Don't use global if you can help it. Sometimes you need it, occasionally. And if we look at test global, look, it's similar. I mean, self dot is accessing an instance of a class. We'll look at classes later. Global is saying there's a name out there somewhere that I want to use directly, and I want to be able to overwrite it, not just read it. In a class structure? I'm sorry? Could. Not a good idea, probably. There's usually a better way to do it. There's almost always a better way than using a global when used, but almost. Again, emphasis on the almost, right? These are rules of thumb. So you can see that there is no local X there because the global prevented it from being created. Python 3 added a non-local keyword, which you see right here. All right. So I'm not going to go through this too slowly, but you can see X is 5. Non-local X is going to refer to the 5, but not refer to the global. Right? So global, it's like, give me my local one or go for the global. Non-local means, well, just go up as far as you need. Well, actually, I don't know if it's far up as far. I assume it says go up as far as you need to find it, as opposed to go up one level. I actually don't know if that's true, but I expect it is. So we define this function, and it'll show us the various values. Let's just make sure X is 1 ahead of time. Yep. And then we got test on local X is 5, and then it becomes 6. But the global X is still going to be 1. Okay. Okay. By the way, I forgot to mention, you notice I'm going from section, I can't remember what number, but we're at 5.4 already. I left these numbers the same as the Epiphanies tutorial, the video, in case you want to reference it or do that one, or look at the similar numbering scheme from the PyCon video I did back in April. So these are captions. These are some of the sections I've cut to get us done in 90 minutes. So can functions modify what's passed to them? Right? Is Python by reference, by value? What's going on? Well, if with our either renewed or deeper understanding of how names work in Python, hopefully this will be really clear to you. Right? So let's try this function. So test 1a, I pass it s, and it's going to try to do a plus equal operation on it. All right? And so if I say s1 equals 1, that's good. If I call test1 and pass it s1, what will s1 be inside? Well, we'll see the 1, and then we'll see the 1, 2, and what will s1 be afterwards? It will be 1. It won't be 1, 2. Right? So this function does some operations. This function does almost the same operation. Instead of a plus equal, I'm using an s equal s plus 2, which, by the way, is not only syntactic sugar. There's actually, depending, the object may implement plus equal as a different operation than the plus. So it's not just syntactic sugar, and that's important in a few cases. But the point is, if we see it this way, let's make that one change, and let's make the other change. Let's just pass in the string 1. Strings are immutable. You can't change the value of a string. You can just create new ones. Right? Well, if we do that, then looking at this code, it should be more obvious to you that when we're done, the 1's still going to be 1. Right? And I mean, I can't even really tell you that, right? It is. I mean, we could print it again, but the point is that might be a little clearer to see that these are really functionally very, very similar. And then this is sort of the description of what's going on, right? So in here, in both cases, in both functions, 1a and 1b, can I get them both on the screen? Yes. In both cases, what's happening is the string s, which is one is being concatenated with the string two, creating a new string, and then there's a namespace operation going on somewhere to remember that. And that namespace operation is here, the s, or s equal. Right? So plus equal and equal are both, they sort of are namespace operation depending on how they're implemented. Okay. So let's try this with a list. So same code, pretty much, except I've added, it's just changed, instead of S, it's M, and instead of 2, it's square bracket 4, a single list, a list with a single value, which is the integer 4. Right? So let's create a list, make sure it hasn't changed. Right? I feel like a magician. Let's make sure it's really what I just said it was. Right? And when we're done, what value does M1 have? Or maybe better said, what object does M1 refer to, and what does that object have? Right? Well, what was passed to test 2A was a reference. Right? So when I say here, when I say M1, I'm asking Python to look in the current namespace and give me back a reference to an object. When I call test2A and say M1 here, Python looks up the M1, gets back the reference, passes that reference off to the function. In the function, a new name is created by this namespace operation in the def, which says, oh, I want a name here called M, which refers, and it could have been S or M7 or whatever, which refers to whatever reference, like in this function, that reference that was passed in, we can use the name M. And then here we said, well, take that object, and what happens here actually is the M in this case refers to that list. It's a second name M for the same one, so now there are 2 names M pointing at the same list, one in the global scope, one in the local function scope. And then it calls the plus equal operation on that list, which basically asks the list to extend itself or to add something to it. It's saying, here list, here's a new list. Please change your contents to be the new list. Right? And just to prove that I'm not lying to you, there's the list changed. Okay? So as long as you think about the names and the references to the objects, then what the function does, is it changing the object or not? That's the question. Whether or not they're mutable or immutable, that's often there's a strong correlation. Immutable things can't be changed by the function call, but it really has to do with the names and the references passed in. I saw a couple questions.
Is it right to say then if you're trying to avoid using globals, that if you're going to modify a global variable, you should pass it into a function?
That would be, in general, better. Probably always better than using global. I don't know. The cases where you need global, you really need it, and it's these edge cases that are all kind of different. But in general, that would be a good plan. Yep. And many people would say, and I think I'm becoming more, saying this more often myself, is if you are passing something in, well, if you can, there are sometimes efficiencies to passing in an object and having it come back changed. There are some reasoning and testing reasons why it's better to pass in an object and get back a new object that shows the change. And those are sometimes in tension, the efficiency performance versus keeping something purely functional. Okay? All right. So let's look at classes. This is kind of a fun section. Let's talk about classes first at the high level, and then I'll show you how things work. The class statement starts a block of code. I didn't say this about the def statement, but same way. I skipped the functions section. It starts a block of code, which creates a new namespace. All namespace changes in the block of code, similar language to all namespace changes are local. Well, I've created a new block of a code block. It's a new namespace. All the changes in that block, everything that's indented under the class statement, is going to make changes to that namespace. And those are things like assignment and function definitions. And then it takes the class name and puts it into the namespace where the class statement appears. It also takes that class name and sticks it in the class object, just like function took it, put it 2 places. Right? And then this part here talks about the method object. When you access an attribute method name on a class instance, an instance of the class, if that name refers to a method in the class, what gets returned when you access that same name on the instance is something called a bound method. Namespace operation. Yep. Yep. Ask me more later. We can keep chatting. Okay, so let's look at a simple little class. Class number. I'm not inheriting from object because I'm running Python 3. I don't need to. It's got, so what are the namespace operations that happen? Well, there's this one, which is an implicit setting of the attribute dunderdoc. There's this one, which is an explicit setting of the attribute dunderversion. There's this one, which is a function definition. So the dunder_init name is going to show up in the number class's namespace, as well as showing up in the code object, the function object that gets created by compiling this thing. And then there's the add, right? So we'll execute that. And let's look at what these do. So what is the number class? It's got an init method, which is going to take 2 arguments, the object that was already created as part of the call to the class, right? So the dunder_init method in Python does not create the object. It's created before that. It's the dunder_new method, which many of you have never heard of and most of us never use, that actually creates the object. The dunder_init just initializes it. And then we want to pass it a second argument, which is amount. So this looks just like a function, and in fact, it is a function. Trust me, you'll see. And then it takes whatever we passed as the second argument and adds an attribute to the object, which the instance, to just save it. And we'll save it with the same name, self.amount, right? And then self.add, well, it's similar. We do a little instrumented here so we can see what's happening. And then it just takes whatever the instance is, looks up its amount attribute, and adds whatever was passed in and returns it. Quite simple. Let's see some fun stuff. So there's the number. So number is now a new name in our namespace. And I can access that namespace looking at its version and its dunderdoc. And I can call help on it, and it gives me that dunderdoc as well as some other stuff that it constructs for me. I can look at its dunder_init, access its dunder_init method, and it gives me back a function, right? So I'm mixing method and function here quite a bit in my names, in the names I'm using. And there's the add function of the number class, or add method of the, which is it? Is it a function or a method? Let's create a little function here and show you that here are the attributes that don't start with double underscore of the number class, right? So that's the way you create an instance of a class. You call, it's a callable, so you can put the parentheses before, after it, the round brackets, and put in this case, I'm passing. I'm not going to do this laboriously, right? You know that the two instance object got created. It creates the instance, dunder_init got called. Okay, so I'm going to call this thing, and now I can look at number.amount because the dunder_init saved it for me in the self. Self was a reference to the object itself. All right, number 2, it's not very pretty. Number2.init. Remember number.init? .dunder_init was a function. Number2.dunder_init is a bound method. All right, so there's proof that what I said before is true, that when we look up an attribute of an instance and it goes up and looks in the superclass to find it as a function, it does something special and returns you a bound method. Okay? Let me digress for a moment. You don't need to understand this to use classes effectively, but it's part of my broader theme of understanding what's going on behind the scenes or under the covers in Python, or under the hood, so you can understand. I think that level of understanding will help you help you move along in language. But don't feel bad if you're not following all of this. Number2.add, same thing, bound method. All right, so if we look at what's in number 2, we see add an amount. We can actually see the only difference is that amount is an attribute on the instance. It's not an attribute in the class, right? Because it was inside the self that it added it as an attribute of the instance. Where does it add it? In its dunderdict. Does number, the class, have a dunderdict? Yes, but it does not have add in it. Okay, so number, the class, has its own dunderdict that we're not going to worry about. It does interesting things with it that we don't care about. It's the dunderdict on the instance that holds the amount. And add, oh wait, yeah. So, yeah, the other thing I want to point out here is that, so where's add? It's not in number 2's dunderdict, but it gets it from numbers, okay? And it's that referencing up. I think I've said that clear enough already. Okay, so let's, there's the bound method, and we can call it. Phew, finally. So we call it, and it tells us that it called it, and it returns a 5, right? It took the self.amount, added, which was 2, added the 3, got the 5, returned the 5. Let me show you some unusual stuff here. So number.add is, we can see it's that function. So this, I'm just showing you the reference. I'm not going to evaluate it, no need. I'm just showing you what the method definition was up in the number class. So if I call number.add with the number 2, I should get back what? I don't know, what number? What's it going to do? It's going to call the function. There's a function add in the class, and what error will I get? What's that? I think I heard someone say self is undefined, which is not, it won't even get that far. It's going to say, sorry, you didn't even pass me the right number of arguments, right? Okay, so let's pass it the right number of arguments. How will this fail? Self's going to be defined, amounts can be defined. Self.amount is not going to be defined because 2 does not have an amount attribute, which is the value 2, right? So there we go. Self.amount, attribute error, int object has no attribute amount. Can I do this? Can I call the function in the number class, passing it an instance of the number class and another int? And the answer is yes. And the answer is not yes because it doesn't look and say, is number 2 an instance of number? That's not why this worked. The only reason it worked is because the add function looked for a first parameter and tried to use its amounts attribute, and it tried to add that to the second parameter, right? Duck typing. This is, Python works, it's not doing, the only magic, there's no magic here, right? It just worked because we passed the right number of parameters, and the parameters could do what we asked them to do. In the case of self, return an amount, get an amount attribute off them.
You have more than one parameter.
What's that?
You have more than one parameter. Number 2 has a parameter, right?
The number 2 was passed as the first parameter to the add function in the number class.
Number 2 resolves as a number integer, right? Number 2.
The number 2 is an instance of the number class, and in the function add, it was named self. Okay, so of course the right way to do that is this, right? So don't do what I did. Okay, now let's do some more interesting thing. Remember the dunder init function that we declared in the class, or we added to class? If we look at the number.init, yeah, we can do help on it just to see what it looks like a little bit. Take self and amount. Well, let's create a function. This is the one I'm going to evaluate. Let's create a function called set double amount. It takes 2 parameters, number and amount. And it looks a lot like the dunder init, except instead of self, I'm using number, but self is just a convention anyway. And instead of equal amount, I'm saying 2 times amount. Now I'm going to do this. Cool. That works. So now numbers dunder init attribute is a function just like it was a function before. It's a different function this time. It even has a different name. You notice the names are different here because I did it via an assignment instead of via a definition in the class, right? But we don't care. It doesn't matter what the name of the function is when you call it. You just have to get to the object somehow. And if we do a help on it, okay, fine. All right. So if I do that, did it work? It did. Okay? That's monkey patching. If you've heard of monkey patching, well, this is it. Or dynamically doing something to a class that you shouldn't do dynamically. You should do it through a class, typically, or a meta class, or something more controlled. Although I did have one student 2 years ago come back to me and say, we actually found a need for monkey patching in production. And the kind of stuff they were doing, I believed it. Anyway, for some definition of the word need. So number 4, can I add 5 to it? Well, sure, that'll work. And if I look at number 4's init function or method, well, again, we call them methods when they're defined in the class. In terms of the actual objects in the class, when you access them in the class, they're just a function as far as Python is concerned. When you access them from the instance, you get something back, which is a bound method. So method is the right term, even at the class level. I've been calling them functions at the class level to show the distinction. Right? And number 2 is an int method. Of course, that was, remember we changed number 4. Number 4 was created after the number class was monkey patched. So number 2 is an int method, or init attribute. It should be the old one? Well, no, of course not, because it doesn't store it with the instance. That's stored up in the class, right? So number 2 that was created before I monkey patched number, the capital N number class, its dunder init method, sorry, dunder init attribute now also refers to the set double amount method that I monkey patched in. Okay? Okay, let's add multiply. Whew. This is a really interesting class. It's got multiply now. All right, so let's add it. It's there, and we call it, and I get an error. All right, so I added it, and multiply by missing one required positional argument value. So it only got past one argument. Before, it got past 2 arguments. What's the difference? What's going on? Well, here's a hint, right? It says it's a function. It doesn't say it's a bound method, right? So can I call it like it's really a function, sort of the way I did number.add earlier? Capital N number add? Yeah, I can. So it's a function. It's not a bound method. And the answer is, where's the mistake? Is I added, you'll see it if we do this. Let's create a new instance of the new number, the new monkey patch number, and let's look at its. We can't even find it, right? So number 10, we've got this number class, we've got number 4, and we've got number 10. If we look at number 10's mul method, it can't even find it when it goes, it can't find it on the instance, can't find it in the class. Why? Because I put it on the instance before. So I did a bad mistake with my bad monkey patching. Right? And we can see public there. There's number 10's got, it's got both add and amount. These are the things you can get to, but one of them's coming from the, but in this case, amount, well, right? The add is coming from the class, but not the multiply by. There's no mul in this list, and there's no mul in this list. Whereas if we look at number 4, well, there's the mul. It's only on the instance. So what we need to do is put it on the class. Right? So now number 10's mul is going to work. And of course, number 4's mul should work too, right? Why not? Why is number 4's not? I put it in the right place. Well, let's look at the dir public. Yeah, it's there. Let's look at its dunder dict. Ah, okay. So now I put it on the instance instead of on the class. I fixed it by putting it on the class. I never removed it from the instance. So this instance, number 10, gets it from the class. This instance got it in 2 places in a sense. It's got it on the instance and on the class. It gets the instance first. So it's returning a function, not a bound method. Right? So a simple namespace operation will fix that. And now I can see that the dict only has what it should. It still shows up as one of the attributes you can get to from number 4. Hang on just a second. And it's a bound method when I access it. When I look at the class, it shows up as a function object, and I can call it.
Why was it a problem that it was a function and not a method?
Good segue. I think. We'll see. I think this will help it become clear. It might not. So how does this actually work? What's going on with classes in Python? Okay, so here's the number class. It's got, here's number 4, which is this object, the instance of the class number. Here's the add function, and here's the add method, right? And again, when I say the, I'm feeling a little bit bad about calling this a function. Number.add is a method, but when you access it directly on the class, it returns a function. So this is part of the magic I'm trying to get you to understand of what Python's doing behind the scenes. By the way, bound methods by themselves are nice, right? If I want to create a new function, which adds whatever you pass to it, it adds 4 to it, I can just go like this. I just say, let me save number 4's add attribute, which returns me a bound method, save it with another name, and it looks a lot like a function, doesn't it? I can say add to 4, 6, and I'll get back 10. And that will live beyond any other stuff getting deleted, because there's a reference to it. Okay, so number 4, those are the...
But add to 4 always references number 4's self?
Yep.
Its amount?
Yep, that's what's coming. So if we look at number 4's add, number 4.add, so I'm going to look at this bound method that when I access the add attribute on the instance, I get back an object, which is a bound method. That bound method has a bunch of stuff in it, including some public things. Well, not many, actually. Look at that. So if I look at the difference there, those are the ones that are different between what the class function has as attributes and the bound method that gets returned that wraps the function returns, right? The attributes of that. So the difference is the bound method has everything that the function has, plus it has a dunder func and a dunder self. Well, let's look at dunder self. It's the instance. So number 4's adds dunder self is the same object that number 4 refers to. Okay? There's proof. I used is to say, are they the same? Yep, those two names refer to the same thing. And number 4's adds attribute, which returns a bound method's func attribute, is the function from the class, right? And it's also the same as that, right? So these bound methods are all sharing, these bound method object gets returned, they're all using a reference to the function to do their work. So when I say number 4.add 5, it's pretty much like I said this. Number 4.add under func. It calls this function, passing it this self, and passing it the 5. So that's actually how Python does method lookup and calls. Pretty easy, eh? You could have written that. I mean, like you think about Python, what's nice, one of the really nice things about Python, lots of things. One is it's consistent in lots of places, and the other is it just it exposes this stuff so we can play with it, and it just implements it by the stuff it exposes. Ooh, 7 minutes. So the question that I didn't answer, if it's still a question, ask me afterwards, please. So just give me another 10 seconds to decide. I will fly 7 minutes. I will just fly through the next 3 sections. So this one, you can create a class by creating functions and then calling the type built-in function and passing it a certain set of things. You pass it the name, and here's how you can see how it actually happens in both places. You pass it the list of superclasses, base classes, sorry, and then you pass it a dictionary, which is the attributes to create. That's actually how metaclasses work in Python. If you ever wondered what a metaclass is, a metaclass is a class with some notation different in Python 2 and 3, which says, don't use the type function, use this other function that I'm providing for you. And that other function, of course, is, well, not of course, but it's going to do some fancy stuff and then call the type function to finish the work. Or possibly call the type function and then finish some work. So it sort of lets you stick some stuff into the, that's exactly how metaclasses work. So anyway, if I do this, it all just works. Although you might want to be careful. You notice here I use the word number here, and I use the word number here, the same string. That's a good idea to keep those the same. And there's the normal way to create it. Okay, I'm going to skip the exercise one. But this is a really cool exercise. If you've ever wondered, if you're still confused by decorators and how they work, this example and the examples that I didn't include that you can get from the off the O'Reilly's site's fuller version of this, or the download, will help you think about decorators just about a namespace operation. The namespace operation, which is a decorator. And I think that for a lot of people can sort of go, oh, it's simple. And then you can start thinking about, instead of trying to think about the namespace operation and what decorators are good for, you can think about them separately. Anyway, I'm going to skip this part. It's kind of interesting. I'm going to show you a couple little examples for generator functions. Let me just show you these two examples. So why use generator functions? They're more efficient. They don't chew up a lot of RAM. They're also simpler, right? Here is a generator function. You just use a yield instead of a return, and it turns it into an object that you can play with when you go run this code later if you decide to, right? There's version 1, version 2. Anyone want to argue that version 2 is simpler? Like version 1 is less lines of code. We don't have to worry about saving the result. We just let the yield do it for us. And you use them the same way, right? They work the same in terms of a for loop. And then here's some more another example of one. So the last 3 sections I want to maybe cover in 4 minutes is just a couple examples with the first class objects. So I want to create a function that is a little mini calculator that works with 3 characters. And the reason I'm showing you this example is many of you, if you are, as you're learning Python, one of the things you need to work against is the narrowing of your imagination that you learned, that you were taught by all the other languages you've used in the past. Right? In Python, you can do things you can't do in other languages. And I've got 2 or 3 examples here that try to help you say, oh, let me think of other ways of doing this. And that's one of the things that's, I think, can take a long time in Python, is to think beyond what you're used to thinking, right? If you're used to using the hammer, and then someone gives you a pair of pliers, well, what do I do with these pair of pliers? You keep solving it the old way. Think of new ways. So let me just run through this quick example, and I think that we'll end with that. So 7 plus 3, I want to iteratively develop a function that lets me pass that string to a calc function and computes the answer. So here's one way. I'll just do the expression equals, and then I've got it in a name. I'll do this tuple unpacking. Right? I'll convert the strings to ints. I'll move them around. Right? So now I've got the plus and the 7 and the 3, and now I can just do a little if plus, minus, minus, slash, slash. So this works, but you notice there's a lot of duplication in here. The only thing different is the plus in quotes and the plus not in single quotes, etc. But we can see that this works. And if we call perform operation, it works. So let's instead import operator, which is a module in the standard library that exposes all the built-in operators as names. Once you have it as a name, you can call it like that. I can just say add 7, 3, the same thing that runs the same code that if you put 7 plus 3 runs. Now I can create a dictionary. And here, again, most of you say, oh, you can do that in Python, but this is something you can't do in a lot of other languages. Is I can have a dictionary that maps from a single character and maps to an object. Well, of course it's an object. Everything in Python is an object. This is an object which is a function, so you can call it. Right? So I create that mapping, and now I can actually access the function, and I can call the function, right? So I can say, give me the function that's stored in the dictionary under the key plus, call it, passing it 7 and 3, and I get back to 10. Nice. So now I can change my perform operation to just do that instead of the if, then, if, the 3 if statements. All right? And I'll wrap it all up in my calc function that pulls together those pieces of code, and calc 7 plus 3 works, and calc 9 minus 5 works, and calc 9 slash 3 works, and calc 3 times 4 doesn't work. And if I want to fix this, I don't need to go add an if statement. I just change the data structure that is encoding what I want to do. Right? So a simple little example. I have another example here that I'm going to skip, and an example further on with just more general treatment of how various ways you can bind data with functions, which is what the bound method does, but there's lots of other ways to do it as well. So thanks for coming. I encourage you to go download the fuller site thing and play with it yourself, or watch the video, or look at the PyCon video. Feel free to come bug me afterwards with questions. I hope it was helpful. You can go to the PyCon website, PyCon 5 video, and look for it. You can go buy it from O'Reilly. That's the newer version. This one, the PyCon one's slightly older. Okay.